a lot about equations or linear equations or how to solve the linear equations. Today we're going to learn something extended from equations, which we call inequalities. So inequalities, well, recall from the equation the reason that or the way how we can construct the equation based on the equal quantity on both sides of the equation, right? So, or in short, the expressions on the left-hand side of the equation equals the expression on the right-hand side of the equation. But of course, we would also have the scenario such that the expressions are not equal to each other on both sides, on either sides. So, for example, what happened to the expressions that are not equal? For example, I have 2 plus 7 as one expression, even though these are all constant, but it is also an expression, right? It's a constant expression. So I have one expression as 2 plus 7. I have the other expression as just a constant term 5. Apparently, this is 9, this is 5. They are not equal. So I obviously cannot build an equation around that. They're not equal. So how can I express or indicating the relationship between these two expressions? I can still write them together in a inequality. For example, I can tell that 2 plus 7, which equals to 9, that is greater than 5. So I'm writing this notation indicating greater than. Of course, I'm reading this from left-hand side to right-hand side. So 9 is greater than 5. And if I'm changing the order, then I'm using the opposite way of this notation, indicating less than. Again, we're always read from left to right, so then this reads 5 is less than 2 plus 7, which is 9. So basically, these two symbols are the symbols for inequalities when we write out two expressions that are not equal to each other. So this is also called strict inequality. Because this means greater than and less than. We also have the case that 2 plus 7 greater or equal to 9 if this becomes 9. So, or 9 less than or equal to 2 plus 7. So we also have the case that this could potentially equals between the two expressions. This is not a very good example because constant won't have this scenario, but later on when we use the unknown variables, you will see many cases that you either have this strict inequality or you have non-strict inequality. Basically, this symbol, if adding a straight line below, it's called greater than or equal to. Similarly, if you write in this way, have a straight line below, this is called less than or equal to. And this is called non-strict inequalities. Okay, so then if further demonstrating them from number line, for example, this time I have y less than or equal to 3. This is an inequality, right? I have constant term, I have unknown variables, and I don't have an equal sign, but I have a less than and equal to sign. So this is a inequality. I can still trying to solve or looking for the value of y from here. It's just I don't have one unique solution. Unlike the equation, you usually solve a unique solution from one equation, but here you will solve a range of number from inequality. In this very simple example, we can demonstrate this from the number line. Right? For example, y less than 3 means if I starting from number 3, all the numbers on the left-hand side of 3 satisfy this condition, including the value of 3. So usually if it's including, we use a solid dot. So basically this is the usual way that we can graphing the inequality on the number line. If it's equal, we use a solid dot, and then we use a line to cover all the numbers that satisfy this inequality, right? All the numbers less than 3 or equal to 3 will satisfy this condition. For example, 0 less than 3, 3 is equal to 3, 0 is less than 3, minus 1 is less than 3. All the numbers over here is less than 3. So this is one example. Or if I have x greater than 5, let me extend my number line a little bit. This means the value of x that satisfies this inequality should be the numbers that are greater than 5, right? So that means all the numbers greater than 5 would satisfy this. And then does this including number 5 itself? It doesn't, because this is a strict inequality. It's strictly greater than 5. So usually if it's strictly greater than a number, we use a circle, hollow circle, to represent the strict inequality. So the second equation on the number line, the second inequality can be demonstrated in this way on the number line. Okay, after seeing the definition of inequality, we have a couple properties that would be helpful for you to simplify your inequalities. The first property, maybe let's start from an example. If I know that A is taller than B and B is taller than C, can I say that A is taller than C? Yes, I can, right? Intuitively, if you know someone's taller than B and you know B is taller than C, then of course A is taller than C. So how to express this in a mathematical form? So if A is greater than B, right? A is taller than B. If A representing the height, then A is greater than B, and B is greater than C. Then we have A is greater than C. This can be easily proved, right? Because I have A greater than B, I have B further greater than C, then A is greater than C. I can even write this from the number line. If this is A, then B should be smaller over here, somewhere over here, and then C is smaller than B, then C should also on the left-hand side of B. Then C is obviously also lying on the left-hand side of A, so that we can also use the number line to prove that this is true, that A is always greater than C in this situation. So this is true over here. But does that true that instead if we have a greater than b and c is also greater than b, then do I have a greater than c or a less than c? This time we cannot conclude anything from here. Again, intuitively, if I have someone a is taller than b and I have another person c is also taller than b, but you cannot really definitely tell that who is taller between a and c because the benchmarks is not in a direct way, or just in number examples, for example, or for a counter example, for example, a greater than b, I can have 5 greater than 2, I can have 4 greater than 2. Then in this example, I have 5 greater than 4. But I can also have an example that 5 is greater than 2, 8 is also greater than 2. Then I don't have 5. Actually, I have 5 is less than 8. So it's all possible, or it's both possible, so that we cannot conclude in this scenario. So it's only true that A is strictly or non-strictly greater than B. Basically, this can extend to be this for non-strict inequality as well. But simply, if A greater than B, B greater than C, this can be kind of passed through B to C so that A is greater than C. Okay. The next property, let's see, next example. If I know or I have x is greater than y, what happens if I'm adding the same amount on both sides of this inequality? Now remember that when we solve equations, we can add or subtracting the same amounts on both sides of the equation. Can we do the same thing for inequality? Yes, we can. Let me show this or prove this to you by using number line first. If I first know x greater than y, which means x is definitely lying on the right hand side of the y on the number line. Doesn't matter they're positive or negative number, doesn't matter where is the zero, it all doesn't matter. All I need to know is x is greater than y. So x is on the right hand side of the y. If, let me say that x becomes x plus 5, y also becomes y plus 5. Plus 5, as plus 5 means moving to the right hand side on the number line. So x moving 5 steps. So it's somewhere over here. Y is also moving 5 steps. So it's somewhere over here. It could be beyond x or still behind x, doesn't matter. As long as you are both moving the same steps or moving the same distance, then your relationship doesn't change. You are still, x is still on the right hand side of y on the number line, which means this is still greater than that y plus 5. Right? So basically adding the same quantity. Similarly, subtracting the same quantity is the same, right? If you both move to the left hand side under the same distance, under the same number of steps, then your relationship doesn't change. Y is still on the left hand side of x, which means you're still less than x, right? So this proves that if we have, let me write it over here. If I have x greater than y, then I will have x plus or minus a is still greater than y plus minus a. Right? A can be any number, positive or negative, or integer or fractions, any number, as long as it's the same number a on both sides. Okay, now one more example or property. So we checked that the inequality can be passed through when the inequality or the inequality sign doesn't change when adding or subtracting the same number. How about multiplication? If I have x greater than y, then how about 3x compared to 3y? This we can, even though it's multiplication, but we can actually prove it from the known property. Let's say we already know, assume that we already know that this is true. Then we start from the known condition x is greater than y. Now, assuming I already proved that the inequality does not change by adding the same number on both sides, I can first adding x is on both sides, right? Then based on that, it doesn't change your sign. Now this means I have 2x greater than y plus x. Now I know that x is greater than y, so that y plus x is greater than y plus y. Now I'm using this property that I just learned. This passes through because x greater than y. So y plus x is greater than y plus y. Now I have 2x greater than 2y by just simplifying it by combining the terms. I can do this one more step. I'm adding another x on both sides because I'm adding the same quantity. This doesn't change. Then I have 3x greater than 2y plus x. And at the same time, I still have x greater than y. So then this is further greater than 2y plus y. So that I have 3x is greater than 3y. See, now I proved that if I have x greater than y, I always have 3x greater than 3y. And I can keep having this going. I can have 4x greater than 4y. I can have 10x greater than 10y. It can always be proven. Now, we're not in a hurry to have the conclusion yet. We can have another example. For example, how about 2 over 3 times x compared to 2 over 3 times y? Let's see if we can also prove that, or also show which one is greater, or if the sign would change. So this time let's use a different way, or a more efficient way than what we just did over there. Let's use a different way. So first of all, because we know x is greater than y, so if I can add or subtract the same quantity on both sides. So now this time I decide to subtract y on both sides. Then I have x minus y greater than 0. Right? This is quite intuitive, right? If x is greater than y, then of course x minus y is greater than 0. Now we use the property that a positive number times positive number always positive, so that 2 over 3 multiplying x minus y. This time I don't really care about the exact value of these quantities. I only need to know whether it's positive or negative, which means I only want to know whether this is greater than 0 or less than 0. So based on that, if by assumption x minus y is greater than 0, so x minus y together is a positive number, my 2 over 3 is also a positive number, so the product of these two must be a positive number, so it must be greater than 0. Then if I'm simplifying this by redistribute multiplication, I will have 2 over 3x minus 2 over 3y greater than 0. Then if I'm moving this back to the right hand side, I will have 2 over 3x greater than 2 over 3y. So I show that this is also greater than that. Even though if it's not an integer, I can still prove that. So by proving this, I can kind of concluding from here that I'm going to write all the properties on this other side. So I can conclude that if I have x greater than y, and we have, so far we only tried the positive multipliers, right? So to be careful, for all positive a, we have a times x is also always, so if x is greater than y, and we're multiplying a positive number on both sides of the inequality, then we have ax is also greater than ay. Okay. Now, you would, right after this, you would ask what happened to negative numbers. What happened if I multiplying or comparing the negative coefficients? Right? For example, we just showed that 3x is also greater than 3y. So what happens if I'm comparing the minus 2x versus minus 2y? We can actually test with, before trying to prove anything or solve anything, we can always use a very simple number example to just have a quick look to see how it looks like. For example, if I'm letting x equal to 3, letting y equal to 2, this is one simple example. So I have 3 greater than 2, then what happens if I'm multiplying a minus 2? 3 will become minus 6, this becomes minus 4, because they are both negative number, so minus 4 is greater than minus 6. Right? Now it looks like I'm having a change of sign, unlike the positive multiplier. When having a negative multiplier, it looks like I'm having a change of sign. So let's see if we can really prove that. So again, we can start from the known condition that if x is greater than y, then x minus y is greater than 0. This time I'm multiplying a negative, so a negative number multiplying with a positive number is always negative, right? So now I have negative 2 multiplying x minus y. This is negative, this is positive, so the product of the two must be negative. Negative means this is a number that less than 0. See, we have a change of sign here. Then to simplify this, I will have minus 2x plus 2y less than 0. Then you can move this over there if you're not very clear for now. This equivalent to minus 2y on both sides. Note that when you plus or minus a number, it doesn't have a restriction of it must be positive or negative. It works for both positive and negative numbers. So I can do this by subtracting 2y. So then I have minus 2x is less than minus 2y. It's less than. See? So in this example, if x is greater than y, but if you're multiplying the negative factor on both sides, the sign becomes changing from greater than to less than. So that means if we have x greater than y and a is negative, then ax becomes less than ay. The sign changes. So basically, to further summarize this, so if we multiplying the inequality with a negative number, we must reverse the direction of the inequality. Basically, if you're multiplying a negative number, we must reverse the direction. This is very important, and this is different from equation, or this is different from all other properties. So be consider this as a special case and be very careful that multiplying negative number will change the sign of the inequality. Okay, more examples. So describing the numbers that satisfy the following inequalities by using number line. So basically, this is equivalent to ask you to solve the inequality. But this time we're just expressing the solution on the number line. So in the first example, over here we have r is greater than minus 2. Minus 2 is here. This is strictly greater. It's not a it's strictly, so it's a circle. Greater than 2 means all the value on the right hand side of negative 2 would satisfy this condition. Go all the way to the right. So this is the first part, but we have the second part of this. Is r is less than or equal to 4. So this is the non-strict. It's less than or equal to. So I'm using a solid dot. And it's less, so it goes to the left-hand side of this number. So to solving inequalities or more than one inequality from the number line, you take the intersects of all the regions together. Basically, here the intersects is this shadowed area. Basically, all the numbers falls below this intersected area will satisfy this inequality. For example, if 0 is here, 0 is greater than minus 2 and 0 is less than 4, or exactly 4 itself, 4 is less or equal to 4 and 4 is greater than minus 2. So basically this common area or this intersection is the solution to this inequality. Next, we only have two expressions that instead of three, but it's unsimplified yet. So this one you need to simplify the inequality first before you draw this on the number line. Now we can use all these properties to simplify this. First of all, I can subtract 7 on both sides such that the sign doesn't change. So I got 2x less than minus 10. Then I can divide by 2 on both sides, and because, well, divided by 2 equivalent to multiplying by 1 over 2, and because this is a positive number, so I don't need to reverse the sign. Basically, the inequality sign does not change, so I have 2x less than minus 5. Now there's no further simplifications needed than by drawing from the number line. If minus 5 is here, there's no further restriction. I only need x to be less than minus 5. So it's all the regions that on the left-hand side of this number, and with a hollow circle. Let's see one last example. This one, we have 3 times 5 minus 2y greater than equal to 2y minus 9. So again, we need to simplify this before drawing on the number line, and we can again use all those properties that we just learned to simplify this. So 15 minus 6y greater than equal to 2y minus 9. Moving 9 over here, it's similar. If you subtracting and adding numbers, it's same as what you did for the equation. So 15 plus 9 greater than equal to 2y plus 6y. So I have 24 greater than or equal to 8y. Now dividing, be careful. Dividing or multiplying cannot be, well, if it's a negative, then you need to change sign. This time I'm dividing 8. 8 is a positive number, so no need to reverse the sign. So then it's 3. Or again, if I want to write my unknown variable always on the left-hand side, be careful of the sign. You should bring the sign together. So this equivalent to be written as y is less than or equal to 3. So on the number line, if 3 is here, less than equal to means you have a solid dot, and it's all the way to the left-hand side. Okay, so those are the simple examples that to solve or to demonstrate the inequalities on the number line. So next we'll see a couple word problems that you will need to solve this by building an inequality instead of equations. Okay, now let's try to see if we can similarly solve word problem by using inequalities. So the first example, suppose that we have two telephone providers, and the two providers has two different plans. So the first provider A, charges $80 per month as the basic fee, and then it charge additionally $1 for each hour of calling. So that's provider A's deal. Provider B's deal charges only $20 basic fee per month, but plus $4 telephone calling for each hour. So now, apparently, even before you see the question, you will see that you have different base plan, you have different surcharge per hour. So it looks like combining that together, you could have different choices or different combinations for the total cost. Now, let's say if I want to choose provider A, so then how much minutes do you have to use in order to show that, or in order for provider A to be a better deal for me? So let's write them into mathematical expressions. Provider A, $80 basic fee plus $1 per hour. Basically, if I'm using 1 hour this month, I'll be charged $1. If I use 10 hours this month, I'll be charged 1 times 10, which is $10. So that's plan A, or provider A. Now, provider B plan is $20 of the basic charge and 4 times the number of hours you're using as the total cost. So you can see that using different hours would make either provider A is lower or provider B is lower. For example, if I only spend 1 hour, provider A will charge me $81, but provider B will only charge me $24. Looks like provider B is a better deal. But the more hours I talk, like in an extreme case, if I talk 100 hours, then provider B will charge me 400 something, but provider A is only going to charge me 100 something. So, but I want to find the exact number of hours that the cost from provider A is better than B. So that means I need to know how many or how much hours do I use to making the cost of A less than the cost of B, right? Because if the cost of A is less, that proves that provider A deal is a better deal for me. So I want this to be a better deal. So now H will be the variable for the number of hours that being used. So then writing this into a inequality, I have 80 plus H less than 20 plus 4H, right? So this is the inequality I have, and I want to find the value of H, or the range of the values that satisfy this inequality. Now, solving from here, it would be quite straightforward. It is 80 minus 20 less than 4H minus H, 60 less than 3H. So divided by 3, 20 less. So H, 20 less than H, or H greater than 20. So this means if I spend my hours, if I talk more than 20 hours a month, then provider A is a better deal for me. So of course you need to convert, I'm not going to write it down, but you need to convert your solution back into words to answer this question. So this is how to solve a word problem by building the inequality and solve the inequality. So you can see that the solution is not one single number, not one unique number, it's a range of numbers. So as long as I'm talking longer than 20 hours, provider A will be a better deal for me. Okay, let's see the second example, and the last example of this class. So the second example, if I have 308 baseball cards and my friend Tom has 532 cards. So Tom has more cards than me today. But let's say starting tomorrow, Tom decided to give 1 card to each of his 4 friends, including me, and 1 card every day. Then you can imagine that I will receiving 1 more card day by day. Tom will giving out 4 cards because to 4 of his friends day by day. So there are going to be one day that I will have same or I will have more cards than Tom. So then by that day, when I have more cards than Tom, how many cards will I have on that day, right? Because I know that by one day I will have more cards, but how many exactly? So this one, again, try to write down the expressions first. So for example, Tom's cards starting from 532, right? And then he's giving out to 4 of his friends 1 card every day. So which means this number is decreasing by 4 every day. Right? I'm using the variable d representing the number of days. However, this question asking how many cards is not asking how many days, but it's easier to assign my unknown as the number of days. So we'll solve the number of days and then we will find the number of cards. So this is similarly to solving the equations that you don't have to use you don't have to assign your unknown to a directly to your question. You can assign this in an indirect way. So then the number of my cards starting from 308, and then it is increasing by 1 because I'm one of Tom's friends. I'm receiving 1 card per day. So these are the number of cards after d days. Even though I don't yet know what's the value of d, but I know that I'm looking for the day that the total number of my cards is greater than Tom's card, right? So I'm looking for solving this d to make this inequality true. And note that I only need to know 1 day, but this inequality will give you a range of days. And I know that among the range of the days, I need to know the very first day that I have on the day that I have more cards than Tom. So let's solve it first. So mathematically, it's being straightforward. This is plus 4d, and then 532, this will become minus 308. I have 5d greater than 224. So I have d greater than 224 over 5. This is not a rounded number, but it's okay, doesn't matter. So this first is 22 and 4 over 5. It's easier to write this into a mixed number. Like remember, we learned from the fraction that writing into a mixed number, we will know the rounded integer part of the number, and we'll know that what is left over. So apparently, this is a number between 22 and 23, right? And then that means when we say on the day, here, on the day that I have more cards than Tom, so on the day, that day is rounded up to 23, right? Because if d equals 22, it doesn't satisfy this inequality. And the next integer that satisfies this inequality is 23. So it's 23 days later. So then eventually I want to know how many cards that I have. So my cards will be 308 plus the number of 1 times the number of days. So 1 times 23. So it's 308 plus 23. That's 331. Right, so your solution so your solution is such a number. Actually, this is 44. the mixed number is 44. So it's 44 and 4 over 5. So the integer rounded up, the integer that greater than this fraction is 45. So actually, the solved number of days is actually 45. So 45 is the next integer that satisfies this inequality, or that's solved from this inequality. So then this is 308 plus 1 card per day after 45 days. So it's 308 plus 45, which is 353. So I will have 353 cards after that day. So I can check, or I can validate this by further calculate Tom's card to see if I really having more cards than Tom. So I can check the same way. So similarly, Tom will have 532 as the initial amount minus 4 times 45 days. So that Tom will have 532 minus this will be 180, and then subtraction between these two will give you 352. So Tom has 352 and I have 353. I have just one more card than Tom. That's exactly on the day that starting that day I have more cards. So then this is the solution to the question, but I can't validate in this way. Okay, so that's all for this lesson for inequality. So again, to summarize this, you'll see that in many aspects that solving inequality is very similar to solving a equation. The only thing that you need to be careful is be careful multiplying a negative number on both sides, and it's also similar to solving the equation. When you solve the word problem, you can always check the results by plugging back the solution, and you always want to convert the words to mathematical expressions in the same way. It's just instead of looking for the equivalent quantity, you were looking for a greater than or less than relationship, and then solving your unknown variable from this inequality. Okay, so that's all for this class.